Alright, well, hello, my children. So today what I want to show you is how I did this little, I guess, dynamic enemy navigation type deal here. So, as you can see here, when the enemy reaches this little block here, it moves around it. But if I put other blocks around it, it will change its little trajectory. That way it can avoid the blocks. And then if there's no block at all, it'll just go back and forth to its original position. Whoops. Okay, well, that worked anyway. So yeah, this is different than context steering, and it's not the navigation obstacle thing either. I couldn't get either one of those things to work, so I had to make my own little custom code things. That way I can get the enemy to move around blocks and stuff. All right, so I'm just gonna go blow through all this. Here I have a 2D node called level. That's just holding all the objects here. I have a navigation mesh, which allows this navigation agent to move around in. I have a tile map, which I just used the default sprite to create. Here is the enemy. I'll show you how I made or how I constructed that. I have another 2D node called block placement. This was just so I could add and subtract blocks, as you saw here. That's all that was for. And then I have a block in here already, which you already saw. Okay. Now let's go to the enemy here. So with the enemy here, I have a character body 2D. That's just so the character can move around. Sprite, which obviously is obvious, just so you can see it. This obstacle cast is just a raycast 2D. This raycast, once it collides with an object, it's going to check its group, and if it's within a group of whatever we specify, in this case I put it as a group of block, it's going to trigger some code, and then the enemy is going to move around it. And this raycast should always be pointing in the direction that the enemy is currently facing. That way it can detect the things that are in front of it. Obvious is obvious. Then a collision shape, that way it can bump into things. I have a regular node here that has patrol paths. These are just paths for the enemy to move to. I could just put them somewhere on the map and then they can go there. And then, like I said earlier, I was using a navigation agent 2D. And this is just to get the enemy AI to move from point to point. And then put a camera on it. That way it can follow the enemy. All right, I'll get into the code here in just a second. Next up is the block. The block, I also made it a character body 2D. I only did that because I couldn't get the rigid body to play nice with pushing and stuff that I was going to have the enemy, that I was going to have the player do. So I just used a character body 2D because it was just easier to use. So you don't need that for this. That's just what that was for. Sprite 2D, just a regular sprite from the default, and I just made it black so it's different. Collision, so I have all the avoid points. These avoid points here, they're just raycast 2D. North, east, west, and south. When the enemy runs into this block, it's just going to choose one of the base points here. As you can see, this little cross at the tip here, or excuse me, at the base here. That's where it starts. That is the point that the enemy will go to. I used raycast because once the enemy collides with here, it's going to do some math to find out which one is adjacent to it, which point is adjacent to it, and then if it's not colliding with anything, it'll go there. If it is colliding something, then it's not going to do that at all. It's just going to stay stuck, or it's going to move to another point. And then for those raycast 2Ds, you need to have hit from inside. For whatever reason, it doesn't seem to collide with objects unless it's just touching the tip. This allows it, if anything is ever intersecting with the raycast 2D, it will detect it. Okay, so now let's go into the scripts. I'm going to blow through this very quickly. You should have your enemy already set up into a way where it can move from point to point. Obviously, since the character body 2D, here I have three little on-rated variables. They get the navigation mesh. It gets the 2D node for the paths that have all the other paths, and then the obstruction cast, which is that raycast 2D. This is just so I can grab those objects in my code. Speed is obvious, just how fast the enemy's moving. All points, these points are the patrol points for the enemy. I just created an array for it, and then at the ready function, it's going to populate this array with those points. This next point, when I do call this array, this next point will just go through the list and choose the next destination for the enemy. The adjacent threshold, this is what the ADJ stands for, adjacent threshold, is for when the enemy does collide up with the box, it has to do some calculations, and if it's within the threshold of 0.7, it will choose that path. Then after that, we have an enum. This is just all the states. It's just patrol and avoid. That's all I needed. Easy peasy. Then we have the current state, which is equal to null. I set that. That way I can set it in the ready function later. And then we have its all the states in in an array. That way I can select whichever state I need. In this case, patrol and avoid. Okay. So the very first thing we need to do in the ready function is we need to get all the paths that we want the enemy to go to. So for paths in get paths dot get children, which is this right here. This only has 2 children, so it should only give us 2 points. It's going to take those points and it's going to put it inside the array that we made, and that's it's only going to store the global positions. That way the enemy can choose one of those paths. Then after that, if the current state is equal to null, change that current state to patrol. That way, when the game is started, it's already at the patrol state. All right, next up we have current state is equal to patrol. Then it's going to run its patrol function. I just created a variable for its direction. Then I just had the navigation agent have a built-in function. Excuse me, I had the navigation agent use its built-in function target position, and then I asked it to get all positions, or excuse me, all points, and then just get the next point. That way it had a spot to go to. And then we had its direction will be equal to its next position minus whatever the position of the enemy was. We normalized its direction. To a singular length, and then we had its velocity influenced by its direction and its speed. Okay, so next up after that, if current state is equal to avoid, if it's equal to avoid, it's going to trigger the avoid object. It does the exact same thing as the patrol, but except this time it's not going to go for its patrol path. We're going to have it influenced by its nav agent get next path position minus the enemy's global position. How we're going to trigger that avoid state. So here we have find obstruction. That raycast is always going to be checking to see if it's colliding with anything, and if it's colliding with something, it's going to get whatever that collider is, and if that collider is in the group of block, so we've tagged it. It's going to check to see if it's in the group of block because we've tagged it with that. I'll show you that when we go to the block and its script. And then we're going to change the current state to avoid. That way, it's no longer patrolling. It's now going to trigger the avoid state or the avoid object right here. Then after that, we need to find a couple of positions. So here you can see we have get enemy position to block, and then we're going to pass in the block that's currently obstructing it. So as you can see down here, you see it says get enemy position to block, and then this is the passed in block. First thing we want to do is get the enemy position in relation to the block itself. So we know where the enemy is, and we know where the block is. So we're going to get the global position of the enemy, and then we're going to get the global position of the block, and we're going to subtract them, and then we're going to normalize them. Essentially, this is what it's going to do is it's going to convert these two into a length, and then it's just going to give us the direction of those two. Then after that, we're going to do the exact same thing, but this time we're going to do it for the paths. So you can see here, we can say for path and block dot all avoid points. Obviously, it's coming from the block, but there's an array within it that has all the points for it. It's within the script here, but I'll get to that in just a moment. But anyway, it's running through all this entire list, excuse me, its entire array, and it's going to get all those points for us. So after that, we're going to create a block to avoid. Then we're going to get the path here, and we're going to get its global position. So essentially what it's doing is grabbing all these points here, and then it's subtracting it to the enemy. That way it knows the relation of it's going to know the position in relation to the enemy and all those positions. Same thing, it's going to normalize it, get a length, and then keep their directions. So after we get the position of the enemy and we get the position of all the avoid positions, we need to figure out the angle of those positions and the enemy to figure out which points are adjacent to the enemy and the block. That way we can have the enemy choose one of those adjacent points. So here we have enemy block position, a new variable, and you can see here we have enemy current position. So we're just getting the length and direction of the current position of the enemy, and then we're doing the exact same thing for all of those path points. And what this dot product is going to do is it's going to calculate the enemy's angle to the angles of these points, and then it's going to give us back a threshold of those it should give us a threshold between -1 and 1. So the way this is going to work is, if it's -1, we know that the point is behind us. If it's 0, we know that it's adjacent to us. And if it's 1, we know it's facing in the same direction as us, of those angles. So when I was doing the math, I wasn't sure exactly what the threshold should be. So I just experimented with it, and I got 0.7. Seemed to work relatively well. So that's how I got that, and how I figured that out was I just printed out the enemy block position, and then it spat out a couple of numbers, and I was like, all right, let's go within that threshold, which I think was like 0.4 to 0.7, something like that. We get our threshold. The next thing we want to do is to check if those paths are colliding. If the path isn't colliding with anything, we know the space is free. But then we also need to figure out if those paths are adjacent to the enemy. So then we're going to put in here, if the enemy block is less than and equal to a positive adjacent threshold, and the enemy block position is greater than or equal to a negative adjacent threshold, we know that those points are adjacent to it. And if so, we want the navigation agent to set a new target position to the path global position. So essentially it's going to select one of those paths, and then it's going to have it set to the global position of that avoid point. And that's how it's going to go there. Now, a couple of things here. These are built-in functions of the enemy. Let's pop in the enemy. As you can see here, I have a couple of signals that I had added here. So I have a target reached. This target reached here, there we go. This target reached here is for the patrol. If the current state isn't in a void, then we want it to change over to the next position. And then if it ever goes over its maximum point, it just resets the entire list. And then after that, you can see here I got set new state after target reached, which is this thing right here. And all I'm saying is if the current state is equal to the avoid point and it's reached its target, so in this case, if it's after it's done with its avoid, after it's done with its avoid state, I need it to change it back to patrol. That way it can continue doing its rounds. So yeah, that's what that's doing. I think that takes care of the enemy here. Block is super fast, super easy. So as I said before, within the enemy here, the for path and block dot avoid all avoid points, that was this right here. Once the game starts, we have it create a list for us, and then we're gonna shove all of the points within that list. Very similar to what we did with the enemy, but instead of patrol points, those are going to be the avoid points. And then after that, we do the exact same thing. We're going to take all the avoid casts, get their children, and put them in that list. That way we can have access to them. And I think that was it, right? Yeah. That way we have access to them, and then we just run the avoid code for this enemy here. Then we'll have access to all that information. That way you can avoid it. As you can see, it's not perfect. But it's going to work for what I need it to do for my game. So I figured, why not share it with the world? All right. So, yeah. Hopefully you learned something. If you have any questions on how this stuff works, feel free to ask me. If not, it will be on my GitHub eventually within the next couple of days or so. So, yeah. Hope you learned something. And until next time, my children, farewell.